A horizontal force of 25 newtons is applied to a 4 kilogram block, which is initially at rest, on a horizontal table as shown below. The coefficient of kinetic friction between the block and the table is 0.35. By considering the external work done on the block, or otherwise, determine the speed of the block after it has been pushed 3 meters. So now, let's understand the overview of the question. Now, you see that this block is on this table. He says that 25 Newton is pushing it to the right hand side. So it means that this block has a frictional force that is opposing this movement. And then this frictional force is, let's represent it as Fk, because since the block is moving, the frictional force opposing its movement is the kinetic friction. But we know that this block has a weight W, which is equal to the mass times the gravity. So now, what is the mass of this block? The mass is 4 kilograms. And then the gravity is 9.8. So 4 times 9.8 is going to give us 39.2 newtons. So the weight of this block is 39.2 newtons. And since we've calculated the weight, we know that according to Newton's third law, there is supposed to be an equal but opposite force known as the normal reaction. Let's denote that by R. And then this reaction is equal to 39.2 newtons. So now, having understood this, we can then go ahead and then find the speed at which the block was pushed. Now we've calculated the weight. So the next thing is to calculate the kinetic friction. So now kinetic friction is giving us mu k r, where mu k is the coefficient of friction and then r is this reactive force. So therefore kinetic friction Fk is equal to, the coefficient of friction was given us 0.35, and then we calculated the reaction as 39.2 newtons. So this is equal to 0.35 times 39.2 is equal to 13.72 newtons. Now, since we've calculated the kinetic friction, let's come to this force, which is the 25 newtons force. Let's go ahead and calculate the work done in the movement of the block from x equals 0 to x equals 3 meters. Now, we know that from theory, work done is equal to the dot product of the force and then the displacement vector. Now, this is along the x-axis, and therefore the displacement vector is going to be along the x-axis. So we are talking about the I direction. And then the force, the 25 Newton force is also acting in the I direction. So I dot I is equal to 1. And therefore, the work done is just going to be 25 newtons times the distance by which it was moved, which is 3 meters. So this is equal to 25 times 3 is 75 joules. So that's the work done by the 25 Newton force. But this 25 Newton force is opposed by this kinetic frictional force, which is the 13.72 newtons. So let's calculate work done by the kinetic friction. Work done by the kinetic friction is equal to, calculated the frictional force as 13.72 newtons. So we need to multiply by the distance, so times 3 meters, and 13.72 times 3 meters is equal to 41.16 joules. So now let's determine the net work done, which is W net. The net work done is going to be the work done by this force minus the opposing friction, the work done by the opposing friction. So that is going to be 75 joules minus 41.16 joules. And that is equal to 33.84 joules. So now, having found this, let's come to finding the kinetic energy. But remember, the block is initially at rest. It means that the initial kinetic energy, KEI, is equal to 0 because velocity is 0 when the block is initially at rest. So let's calculate the final kinetic energy, and that is equal to half mv squared. So this is equal to half, then the mass of the block that was given was 4 kilograms, so times 4, then v squared, which is equal to 2v squared. So the final kinetic energy is 2v squared. But we know that from theory, work done is equal to final kinetic energy minus initial kinetic energy. But because the initial kinetic energy is 0, then it means that this work done is just equal to the final kinetic energy. And therefore, work done in this case is equal to this 2v squared. So 2v squared. Now, we have this net work done, and we also have work done. So therefore, we can equate the two. So let's assume this is equation 1, and this is equation 2. So equation 1 is equal to equation 2. And therefore, 2v squared is equal to 33.84. So let's divide through by 2 and divide here 2 by 2. Therefore, v squared is equal to 33.84 divided by 2 is equal to 16.92. So we need to take the square root of both sides. And therefore, we find out that v is equal to square root of 16.92 is equal to 4.11 meters per second. So the work done, the speed of the block after it has been pushed 3 meters is 4.11 meters per second.